So when solving a trig equation, you may have heard me say before, it's a good idea to get, number one, the arguments need to be the same, both theta or both 2 theta. Also, try to get the same trig function. So that means that I should use a trig identity for cosine of 2 theta. There's 3 choices, but the one I'm going to use is 1 minus 2 sine squared theta. Because that way, then it will be sine of theta all throughout the problem. And then it was set equal to 1. Now what I could do is subtract 1 from both sides, which means that it's equal to 0. And the next thing we're going to do is factor. This has a sign in it, and this has a sign in it, so we could factor out sine. So that would leave behind negative 2 sine of theta plus 1. And now that it's factored, set each one of these equal to 0. So negative 2 sine of theta plus 1 equals 0. And this one is just sine of theta equals 0. So this one I could do even without a calculator because the sine graph looks like this. And then where it equals 0 would be right here, which is theta equals 0, right here, which is pi, and right here, which is 2 pi. So we get theta equals 0, theta equals pi, and theta equals 2 pi. And actually I should have changed this to be a square bracket because I want to include that 2 pi. Then for this one you could subtract 1 from both sides. And next divide both sides by negative 2, and that's going to be sine equals a half. If you've watched some of the previous podcasts, that showed up before. So actually it's right here. Take sine inverse of a half and you get this decimal. Tell the calculator divide by pi, and what fraction is it? It's 1/6 of pi. So the sine graph would look like this. And then here's 1/2, goes straight across. There's one solution right here, which is at pi over 6. And there's another one right here. And right here where it crosses the x-axis is pi, which means this is at pi minus pi over 6. So just to the left of pi. And that is equal to 5 pi over 6. So it seems like we have 5 answers. 1, 2, 3, 4, 5. So let's see if this is right. So graph the original function. Does it still have those weird lines on it if I lay it flat? Yeah, it does. So I need to angle it up. So erase this old problem. Type in the new one. Cosine of 2 theta, where in this calculator it's x, plus sine of x. And then when does that equal 1? So for the window, go from 0 to 2 pi. That's already set up. I need to see where it's equal to 1. So I could just go from 0 to 2. And that way I could see where it's equal to 1. So there's 1, 2 solutions, 3, 4, and 5. So that one right there is 2 pi. What about trace? What about pi divided by 6? That's correct. 5 pi divided by 6. Yes, that's correct. And pi, yes. And 0, yes. And finally 2 pi. Now I pause right now because sometimes when I type in 2 pi it works and sometimes it doesn't. I'm curious to see what happens this time. Oh good, I'm glad this happened so I could show you what happened. So put goto. It says it does not like 2 pi. The reason is when I did the window, this is going from 0 to 2 pi. Watch, 6.28, I put 2 pi. When I literally say 2 pi, that is the exact value. But as soon as I move the cursor, it puts an approximation. Then what happens on the graph is its approximation cut it off right here, and just off the screen by the tiniest decimal, that's where 2 pi is. So to fix that problem right here, instead of 6.28, just have it be like 6.5. So that'll just widen the window out a little bit more. And then wait for it to graph. And now when I type in the 2 pi, it's going to work. So you'll even be able to see where they intersect right here a little bit better. And go to trace and put 2 pi, and now it works. Okay, so now we're done.